So we're looking at what are we looking at? Okay, calculus or calculus of logs and exponential. Exactly. We said the first thing that we need to know here, the first thing is that if f of x is a function lim u, for us to get the derivative of this function f, we will differentiate u and divide u. You differentiate u and divide it by u. That will be the derivative of. So that's the purpose of lim. That's what lim does to the function in terms of derivatives. That's all. In the derivative, you never get to see lim unless it is part of u again. Well understood. Now with this one, with this, we can have examples. Examples explaining this one. Find dy dx a y is equal to lim 1 plus x to the power 3. Here, you let u to be 1 plus x to the power 3, and then differentiate it. You get 3x squared. Then you will say dy dx is going to be u prime by u. But u prime is 3x squared. So you divide by u, which is 1 plus x squared. I mean 1 plus x to the power 3. This is the solution that we are looking for. Another example, if you are given y is equal to lim, okay, time start noising things. Those questions are forgotten. I don't know what I wrote there, but we have nice man those. This multiplied by x squared. Let's forget about it. So if have this, instead of us using product rule inside as we differentiate u, we can apply the laws of where you say I can write y as lim 1 minus x squared to the power half. Since I'm multiplying, that is plus lim x squared minus 4. Again, allows us to drop the power so that we are in 1 minus x squared plus lim x squared minus 4. At this point, we cannot differentiate. So dy dx is going to be half. The derivative of 1 minus x squared is negative 2x, and then divide by 1 minus x squared. Plus is 2x over x squared minus 4. Simplified as negative x over 1 minus x squared plus 2x over x squared minus 4. Any questions? The next 3 steps are from the laws of logs. The third step is differentiation.
So you multiply half by negative 2x to get negative x?
Yes. Next, they ask.
So are you talking?
No, I'm done. Okay, so to talk. C. Y is equal to of. Hello.
The video.
What's the problem? Over squared minus 4 multiplied by x to the power 1 over 3 multiplied by 3x power 4 minus 1. And you want to differentiate this function. The best way is to apply the ln, that is power 3 minus 1 minus ln of x squared minus 4 to the power half minus ln of x to the power 1 over 3 minus ln of 3x4 minus 1. And then you can still do some simplification here. You drop the half. We have ln x squared minus 4 minus 1 over 3 ln x minus ln 3x4 minus 1. Now we can differentiate. dy dx is going to be 3x squared over x3 minus 1 minus half 2x over x squared minus 4 minus 1 over 3x minus 12x to the power 3 over 3x power 4 minus 1. Simplified as 3x squared over x3 minus 1 minus x over x squared minus 4 minus 1 over 3x minus 12x3 over 3x4 minus 1. You're done.
So
Yes.
that's supposed to be 12x squared. Oh, you don't define. Do you? Don't you differentiate it, sir?
Your differential guys, it was 3x power 4.
Oh, yeah.
Any question?
Yes, I'm kind of asking if you can run me through how you are differentiating.
When you are differentiating, we are saying, if we go back to the original formula for derivatives, that's where everything is starting from. If f of x is equal to nu.
Hello, sir.
Hello.
Yes, I'll pali 1 over 3x. Apo pampanga zaidi hapo. No, the next is right, sir. Yeah, where you have differentiated 1 over 3x.
Okay, let's start from the first slide. If your function is f of x is equal to nu, what you are differentiating is the u. Okay, to differentiate ln, you differentiate u and divide by u. So if I have 1 over 3 ln x, 1 over 3 is a constant multiplied by, I differentiate x, the derivative of x is 1, and then divide by x. This is going to be 1 over 3x. If I have 1 over 2 ln x squared minus 4, 1 over 2 is a constant coefficient, and then I multiply by, I differentiate x squared minus 4. You get 2x, and divide by x squared minus 4. If I have ln 3x to the power 4 minus 1, and I'm differentiating this, I would differentiate 3x squared, 3x to the power 4, I get 2 of x to the power 3, and divide by the whole thing, 3x 4 minus 1. If I have ln x3 minus 1, I would differentiate x3 minus 1, we get 3x squared, and divide by x3 minus 1. And then put this together, you have this line. And then simplify to this one.
Now, sir, if you wanted, can you use quotient rule on this one?
When your ancestors will be shocked. Because within, if it's a test, within 2 hours, you use quotient rule here. How many product rules are
That's it.
I was wondering what you can use to simplify the second line.
Simplify the second line. Which one is second? This one?
Yes, that one.
Which law? That law, okay. That law which says that if there's a power for ln, you can drop a power, it becomes the coefficient. If there's a power, you can drop it, it becomes the coefficient. You remember that law? That's supposed you to remember. Else, if you have log a, x to the power b, is the same log x. That's the one I'm using here to drop the.
No, sir. I mean, it was division, now subtraction. I mean, how that's come up.
Oh, we moved from 1 to 2. Oh, that's how we simplify 2 to 3. From 1 to 2, we're using this property here. This law. If you have log a, x, you get log a, x minus log a, y. That's what we used. It also says that if you have a, x over y, you are going to have log ax. Log ax minus log ay minus log az minus log aw. Log ax minus ay plus log az plus log aw. The same can be in this manner, because where there's multiplication, we separate by addition. Where there's division, we separate by subtraction. Is it okay?
Yes, thank you, sir.
All right. Let's now go to differentiate y is equal to, this was part 1, part C, part D is equal to okay, log 2 x squared plus 1. The base is not, remember, ln is log to the base e. Now 2 is not e, so a difference here. So what do? I first change. So we drive the formula here. Because we are dealing with log a, f of x, and want to differentiate. We first change this. Let's use u, which is log u. We first change the base to e. We're going to have log eu over log e, so that you have ln u over a, and then the derivative now here is going to be, this is the same as 1 over ln a multiplied by ln u, so that we have 1 over ln a as a quotient, differentiate u, then divide by u. Simply say the derivative of such functions is going to be u prime of u in A. So when we come to this setup here, the derivative, we first let u to be x squared plus 1, so that u prime becomes 2x. And then we come here and say u prime over u in 2. U prime is 2x over u is x squared plus 1 multiplied by in 2. That's all. So we have driven the formula. No need to memorize. So if you have forgotten this general formula here, you change the base and differentiate. Simple. If you've forgotten how to change the base and you've forgotten the formula, you skip the question.
So how do you change the base?
Whenever they ask you to expand the ascending part of x, make sure x is the second item.
How do you change the base? If you have log A x, you want to move to log B. You say log B x over log B A. Change the base. That's how we change the base from A to B.
So what about that equation you gave? So how would you change the base?
Which equation?
The one which has log 2.
If you want to change log 2 to E,
Yes.
log 2 1 plus x squared is going to be log E x squared plus 1 over log E 2. But log E is the same as ln, so have ln plus 1 over ln 2.
No, sir. I wanted to ask in terms of when you're changing the bases, how is that one possible to be cancelled?
Which one?
On the log base A, x is equal to log base B x over log base B A. Because we are supposed to cancel them.
You only cancel if they are the same. If they are not the same, why cancel? Why should we cancel?
Oh, sorry. Forgetting.
Another question.
So like sir, like the last one, the one who have just changed the bases, I don't know what you okay, like I'm a bit more behind. So like when we simplify this one, x squared plus 1 divide in 2, like we can still get the same one, like x plus whatever the answer we've just gotten here.
Yes. Because if you have to differentiate this one, we'll say derivative of this guy. First, the ln 2 down here is just a constant. So you differentiate x squared plus 1, we get 2x, and divide by x squared plus 1. Like that.
Okay, sir. Thank you so much.
I did a bit more behind. You catch up. Maybe schools are, baby.
Sir, can you go back to the previous page?
Here's the previous page. Change cruise, man.
Okay, thank you.
Okay. Ya, pacaran ya. Nancara nachukura. Siapa onda? Ok. Let's
Sir,
go
but
to
say 3i.
Take a screenshot.
yeah, clearing
Fine,
either
sir.
Not taking
whether I like it or not, you have to clear.
I mean, sir, motivation, sir. Motivate us more.
Put one there, guys.
Sir, continue. We are using calculus.
There's still screenshotting. Are you done?
When you finish just writing, when you see the sir finish writing, put a screenshot paper not to come meeting jirani na mfaushi.
Easy.
Empire.
Another question. So you've seen that we've changed from E, we've also changed from other bases. Now I want to go to exponential. Exponential, another set of examples. Find dy dx. When y is 2 to the power x. So we know that exponentials don't have that property of dropping the power. It's only logs that have that property. So in such cases, we'll go back to log and bring it in on both sides so that you have ln y is equal to x ln 2. And then differentiate ln y, you get 1, then divide by y. But because you have differentiated y, you write dy dx here. Differentiate x ln 2. Derivative of x is 1, so we remain with only ln 2. And then you are solving for dy dx. So you multiply throughout by y ln 2, but y is 2 to the power x. So that we derive the general formula now. If I have y is equal to a to the power of bx, and I want to differentiate this, I will apply ln, again apply ln a to bx, and then you have ln y is equal to bx ln a. Then differentiate y, you get 1, divide by y, and then dy dx is equal to, differentiate bx, b, and then ln a. Then to get dy dx, multiply throughout by y, but y is a, bx, and then b ln a. This is a general formula, meaning that if you differentiate a equation of this nature, y is equal to 5 to the power 2x plus 1, we differentiate the power, so let u be 2x plus 1, differentiate the guy u, we get 2, and then come to the function and say y prime is going to be 2, that derivative there, ln 5 as the base, and then multiplied by 5, 2x plus 1. I'm just applying this rule here, the general formula. That's how you differentiate. Open for questions now. Yeah, take it easy. Questions? Anyone with a question? You're free to ask.
Okay. Sir, kindly just explain on on part 2. Y is equal to AB. How you are solving?
So y is equal to
on question 2.
Okay, let me run through. Y
So when you are
y
dropping it, meaning you need to drop everything like on step 2.
Okay, watch again. When you apply lin, you also apply lin. Then you keep lin, drop the whole power, bx. Then you remain with lin a. When you differentiate on the left, you differentiate y, you get 1, and then divide by y from the way of differentiating lin. And then because you differentiate y, you write dy dx, which is equal to differentiate b x, you get b. And then ln a is just a constant, it remains there. Then you have dy dx multiplied throughout by y. You get this. But what is y? Y is a to the power bx. And then you have b ln a. That's how it comes out.
Now, sir, I wanted to find out where, if we ask you a question like the way we started there, the y over dx, what about if we ask you like y prime? And then when solving, do you have to consider the y over dx, or just have to stick to y prime?
You can stick to y prime while there's dy dx to y prime. It's the same thing. Even if they say y prime and you find dy dx, you'd have found the same that they want.
So it doesn't matter.
Because y prime is exactly the same as dy dx. Doesn't matter.
Sir, I'm kindly asking if you can explain for me the last part on the third example, how we arrived to 2 ln 5.
So what did we do? We differentiated the power, looking for the b. Okay, so we differentiate the power, we get 2. And then where there is b here, we put 2. Where there is ln a, we put ln 5. Because 5 is the base. And then multiply by the whole 5 to the power 2x plus 1. That is. So we have come to Zoom, where after 40 minutes you have to be kicked out. So let's follow the culture. Log out and log back quickly.